The standard deviation of the weights of elephants is known to be approximately 14 pounds. We wish to construct a 97% confidence interval for the mean weight of newborn elephant calves. 75 newborn elephants are weighed, and the sample mean is 240 pounds. The sample standard deviation is 15. When we compute any of our answers, we're going to round to the nearest hundredth. So in parts A through D, we need to identify these values from this question to start off with. So X bar is the sample mean, and that is given to us right here as 240 pounds. S is the sample standard deviation, which is given to us right here, is 15 pounds. Sigma is our population standard deviation, and that's given to us here as approximately 14 pounds. And I know that this is the population standard deviation because it says it's the standard deviation of the weights of elephants, of all elephants. This isn't from the sample. This one here is from the sample. It identifies it as coming from the 75 elephants that were chosen. The 14 pounds is for all elephants. Now, N is our sample size, which was given to us as 75. So for parts A through D, we just need to identify those values. Now, for parts E and F, we have a little bit of work to do. E is probably going to be where we're doing the most work, where we're trying to find the critical value. When we look at a normal curve, the mean is going to be in the center, which we said was 240. And we want to construct a 97% confidence interval. So in the center, we want this area in the center to be 97% of the weights of baby elephants. All of this data should be between these two values. When we find a confidence interval, we're looking for those cutoff points. What are those two values so that 97% of the data falls between these two values? So to find our critical value, we want to find how far out we are from the mean in terms of standard deviations. That will be our Z, our critical value. In terms of standard deviations, how far out am I from the center? Well, I know there's 3% left over from 100. 97% is in the middle, 3% is left over, and 3% needs to be split up between these two ends. So 1.5% is going to lie in this wing, and 1.5% is going to lie in the higher wing, where the highest values lay. That's this shaded area. So to find our critical value, we want to find this value of Z. So I'm going to use inverse norm, and I'm going to use the percentage 1.5. So I'm going to do inverse norm. I'm going to put in 0.015. Because we want to do this in terms of standard deviations with the standard normal curve, put in that the mu is 0 and the standard deviation is 1, and we're looking for the area to the left. If you do not have this option on your calculator, by default it will give you the area to the left, which is what we're looking for, that 1.5%. Now I'm going to go down and hit enter, and it tells me that my critical value is 2.17. On this end, it's negative 2.17, but on this end, it's 2.17, and that means we're 2.17 standard deviations out from the mean, which is why we have this as our critical value. Now, to find our confidence interval, that's this last part right here, we are going to go to Stat, over to Tests, and I'm going to go down and find Z-interval. I'm using Z-interval because we're doing means. We're looking for the mean population, an interval for that mean population, and we also know what the population standard deviation is. So when that's the case, we use Z-interval. I'm going to hit enter on Z-interval, and I'm going to enter in all the information. Now, if you had actual data to put in, you would use this option, and then you would put what list your data values are in. But since we have the stacks, that's what we're going to use instead. So we're going to put in our population standard deviation, which is 14. We already found that from the problem. We're going to put in our X bar, which is 240. Our sample size is 75. And we're doing this at a confidence level of 97%. The calculator wants you to put it in as a decimal, so put in 0.97, and then we're going to hit calculate. And it will tell us what our interval is. So this tells us that our lower bound is going to be 236.49. So we put in our lower bound, 236.49, and our upper bound was 243.51, and that goes here. So when we read this and look at our final conclusion, we would say we estimate with 97% confidence that the mean weight of all elephants is between, and then you put your lower and your upper bounds. And you get that from your calculator. Remember, this is going to be your lower number on the left, and this is going to be your higher number on the right.